Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. Today, you are going to see the Unit 2 for the subject called Kinematics and Dynamics of Machinery, that is coming under the regulation of 2021. Already, the last previous slides you have seen, one of the video lecture we have seen about part 1 of this Unit 2, that is gear and gear trains. Today we are going to see the upcoming topics and we will solve some problems in this video lecture. So these are the glimpse of the syllabus which I already discussed in the previous videos. So now we can see what is velocity of sliding teeth. Already we have discussed about what is a cycloidal tooth and invalid tooth. We have seen these two types, and now we can see velocity of sliding is the velocity of one tooth relative to its mating tooth along the common tangent at the point of contact. That is important. Velocity of sliding is the velocity of one tooth relative to its mating tooth along a common tangent at the point of contact. That is velocity of point Q considered as a point on wheel 1 along the common tangent TT is represented by EC. In the diagram we can see EC, this is represented. Similar triangle we can take out from this sketch, that is QEC and Q1 MQ. Based on that we can relate these two triangles. We can write EC by MQ equal to V by O1 Q equal to omega 1. Under cross multiplying we can get EC equal to omega 1 MQ. Similarly, velocity of point Q considered as a point on wheel 2 along the common tangent TT is represented by ED from similar triangles QCD and O2NQ, that is ED divided by QN equal to V2 by Q2 Q equal to omega 2. In cross multiplication we will get ED equal to omega 2 QN. Vs is nothing but velocity of sliding at Q. What is Vs? From the sketch we can write ED minus EC is nothing but omega 2 into Qn minus omega 1 MQ. We can write ED. ED already we derived. That's two simplifications we got. Omega 1 MQ. Another one is omega 2 QN. We can take Q2 as common. Sorry, Qn we can write as Qp plus Pn. MQ again we can write as MP minus QP. So we can take the various terms omega 1 plus omega 2 into QP plus omega 2 into Pn minus omega 1 into MP. Since omega 1 by omega 2 equal to Q2 P by Q1 P equal to Pn by MP. Also we can write as Vs is equal to omega 1 plus omega 2 into QP. So these formulas is very important. We are using these formulas for solving the problems. Length of path of contact is very important, and we are using this formula for solving the problems. So length of path of contact is the length of common normal cut off by the addendum circles of the wheel and the pinion. This representation of this sketch represents the length of path of contact, how the length of path of contact we are getting in this diagram. That is represents KL is the length of path of contact, that is KL. KL equal to KP plus PL. KP equal to length of path of approach. These two things is very important. And the path of recess. That is approach means it is getting contact with one another. Recess means getting disengaged. That is the important thing. RA equal to O1L. Radius of addendum circle of the pinion. R capital RA is nothing but radius of the addendum circle of the gear. Pinion is the smaller one. Gear is the bigger diameter. R is the O1P, radius of PCD, pitch circle diameter of the pinion. O2P, that is capital R, radius of PCD, circle of the gear. These are the basic formulas. So under derivations, we are obtaining two various important formulas. One is length of path of contact, that is path of recess, and path of approach. Upon adding these two, we will get length of path of contact. So length of that is path of approach, we already got as root of RA square minus R square cos square phi minus R sin phi, and as well as path of recess PL equal to ML minus MP, root of RA square minus R square cos square phi minus R sin phi. On summation, we will get this expression. That is, adding the above two equations, we will get this expression, that is root of RA square minus R square cos square phi plus small RA square minus R square cos square phi minus R plus R sin phi. So length of arc of contact, as I already told, length of path of contact is over. Length of that is arc of contact is the path traced by a point on the pitch circle from the beginning to the end of the engagement. So whenever the two gears are going to get meshed together, that is beginning to the end of the engagement. Beginning to the end of the engagement of the given pair of teeth, that is the arc of contact. That is, length of arc of approach is nothing but Kp by cos phi. Length of arc of recess, that is length of path of recess divided by cos phi, equal to PL by cos phi. Length of arc of contact is equal to length of path of contact divided by cos phi, equal to KL by cos phi. Contact ratio, or the number of pairs of teeth in contact, is defined as the ratio of the length of arc of the contact to the circular pitch. Contact ratio is given by length of arc of contact divided by PC. PC is nothing but circular pitch, which is equal to pi m. M is the module. This is one basic problem we have took here. That is, pinion having 30 teeth drives a gear having 80 teeth. So 30 teeth is a smaller one. 80 teeth having a bigger one diameter. The profile of the gear is involved with 20-degree pressure angle and 12 mm module and 10 mm addendum. Find the length of path of contact, arc of contact, and the contact ratio. Students, you have to study only the formulas, the basic formulas. If you are thorough in this, you can clearly solve this problem. We have to take the given data, that is must. After getting the given data, under which formula we have to use, under which terms we are using these values, that is very, very important. The T is equal to small t. Small gear we are represented by small t. 30 number of teeth, bigger T 80, pi is 20, m is 12 mm, that is module, it is given. Addendum 10 mm. Length of path of contact, we know that pitch circle radius of the pinion is nothing but R equal to, this is the basic formula, R is equal to mt by 2, that is 12 into 30 by 2. By using the formula, we will get that 480 mm, that is the pitch circle radius of the gear. Then radius of the addendum circle of the pinion, that is RA equal to R plus addendum, that is 180 plus 10, that is 190 mm. Radius of addendum circle of the gear, that is RA equal to R plus addendum, that is 480 plus 10, that is 490. Length of path of approach, that is Kp equal to RA square minus R square cos square phi minus R sin phi. This formula we have already discussed in the previous slides. Basics, direct substitution the values in the formulas, and you will get 27.3 mm as the path of approach. Path of reverse is 25 mm. Upon summation of these two values, you will get 52.3, that is Kp plus Pl. Length of arc of contact is nothing but length of path of contact divided by cos phi, that is 52.3 divided by cos 20, we will get 55.66 mm. Contact ratio, circular pitch, is nothing but PC is equal to pi m. Pi into 12. 12 is nothing but module. We will get 37.7 mm. Contact ratio is nothing but length of arc of contact divided by PC. You will get 55.66 upon 37.7, approximately 1.5. Problem number 2, the same thing. Again, we are using the same formulas. In this formula, in this problem, we are having the pressure angle of 20, teeth 20, small teeth, and the gear ratio is given. So we can use the formula capital T by small t, which is equal to 2. Pitch expressed in the module is that is 5 mm is the module. Pitch line speed, one extra data that is given, V equal to 1.2 meter per second. Addendum 1 module that is clearly given in the problem. Addendum is equal to 1 module, therefore we are taking 1 module. Module it is given 5 mm, so 1 module equal to 5 mm. Then directly we are using the formula to find the angle turned by the pinion when one pair of teeth is in mesh. We are using the formula R equal to mt by t, that is 50 mm. Capital R equal to mt by 2, 100 mm. The radius of addendum circle of pinion is nothing but Ra, R plus addendum. Then Ra equal to capital R equal to R plus addendum, again 55 mm, 105 mm. Then again use the same formulas Kp and Pl what we have discussed in the previous problem. Kp formula already we know that. We are using the formula and getting the value of 12.665 mm, and Pl is nothing but that is length of path of resistance is 11.5. Length of path of conduit is nothing but summation of these two values Kp plus Pl, 24.15. What is length of arc of conduit? That is length of path of conduit divided by cos phi, that is 25.7 mm we will get. Angle turned by the pinion is nothing but length of arc of conduct divided by circumference of the pinion into 360 degree. Already we got length of arc of conduct, that is nothing but 25.7 into 360 degree divided by 2 pi into 50. We are getting 29.45 degree. Maximum velocity of sliding, we are using the formulas Vs is equal to omega 1 plus omega 2 into Kp. Kp already we got in the previous slide of this problem. Omega 1 is nothing but V by small r. Omega 2 equal to V by capital R. V will be constant for these two, 120. And small r 5 and bigger r is 10. And finally, we upon substituting, we will get 455.4 mm per second. So these are the two references which I took for preparing this content. Kindly go through this. So thank you all. Thank you one and all students. Kindly go through these topics and the formulas and what are the problems you have solved. Go through it. Kindly subscribe the channel. So please like the video and share to your friends. So in upcoming lecture we will see in the next topic of this unit 2. Thank you.